So moving into section 6, we'll be doing problem solving, word problems. I get it. A lot of students aren't huge fans of this. But it is important, like, all of these problems that are, I guess, easy for students that they can follow along and they can solve for X. But it really doesn't mean anything unless you can apply it to word problems and problem solving. So we had a section like this earlier where we had all variables and asked to solve for a particular variable, which is exactly what's happening here. Like, they want you to solve for X, and I will accept multiple correct answers because the way my brain works is I would want to get rid of all of these denominators, by multiplying everything by X, Y, and Z. And so as you distribute X, Y, Z, well, the X's would cancel, so you'd be left with Y, Z, and then the Y's would cancel, so you'd be left with X, Z, and on this side, the Z's would cancel, so you'd be left with X, Y. Now, the way I would solve it is I would get all the X's on the same side. So I would, rewrite it as XY minus XZ by subtracting that X over. So I could GCF, greatest common factor, out in X equals YZ. And then it's a multiplication problem, so to solve for X would be division. So, YZ on the left side divided by Y minus Z. And then there's a little caveat on here where X, Y, and Z cannot equal 0, but I'll forgive you those points if anybody thinks of it that way. I realize that there's other ways of doing this, like, some of you might have tried this on your own where maybe you start off with rewriting the problem as 1Z minus 1Y. And then, even from there, you'd probably want to do another step like this because, you'd probably want to get rid of those denominators. So I realize that there's other ways of solving for a variable. It's just not how I would do this. Obviously, I'm showing you the way I would answer the questions. But if you follow along in the book, you might have a slightly different way of doing this. As you look at exercise 2, I'm not a big fan of the way the book phrases this, but I copied it verbatim on page 452 if you're following along in your book. So if you find a number that when added to the numerator, so X plus in the numerator, how do they? I'm going to try and do this the same way the book does it. So let me erase that. So they start with a fraction of 3/11ths, and the same number. So I would have been fine if I left as X plus 3 in the numerator, and that same number is subtracted from the denominator. Yeah, that's how they. Although the problem in the book is a little bit different, but anyway, and the equivalent, the final answer is 5/2. So what we have to do is find that value, and the way I would solve this problem is by again getting that same denominator. So multiplying. Well, how about this? Let me just switch up how I teach this. So sometimes teachers will explain with cross multiplication, and we can do that. There's nothing wrong with that. So just make sure that when you cross multiply that you distribute. So it becomes 6 plus 2x. And then the other cross product will be 55 minus 5x. So as I'm looking at this, I'd probably add 5x to the left side and subtract 6 to the right. So on the left side, I have 7x. Now on the right side, I believe that's 49. And then divide by 7, and you would get x equals 7. Again, I don't know if you've noticed, but I just followed directly from the book. And sometimes I'm not a fan of how the question's worded. But once you set up the equation, the math is pretty straightforward. At least this one you can cross multiply and just make sure you distribute as you cross multiply. So moving on to example 3. Again, the first thing is to read and understand the question. So in the United States, 1 out of 12 homes is heated by fuel oil. At this rate, how many homes in a community of 36,000 homes are heated by fuel oil? Um, I would just set this up as a proportion, which is how I'm thinking. So 1 out of 12 homes is heated by fuel oil. So if we had 36,000 homes in the community, now I would just stick an X in here. And I recognize that some of you might just cross multiply or understand, oh, well, if it's 36,000 divided by 12, well, I guess I can show you the math behind it if anybody's a fan of cross multiplication. Well, 1 times 36,000 is 36,000. And the other cross product would be 12x. So to solve that problem, you would divide by 12 over, which is the work that I was about to write down. 36 divided by 12 is 3, so we're looking at 3,000 homes. So exercise 4, if I think this is where it starts to get very, I would say, daunting of a task. And every year I do this, somebody gives me a ridiculous answer, and I get why, because these are difficult problems. But I've seen problems where students will actually look at this and say, oh, somebody can do it in 3 hours and somebody else can do it in 2 hours. They might give me an answer of working together, it takes them 5 hours. Well, that doesn't really make sense. And the reason why I say it that way is I would imagine that if Bill worked by himself and did the job in 2 hours, then any help he gets, he should get being working together, they should get the job done faster than 2 hours. So this is why I reference students to look on page 454 and actually work through the problem. I'm sure you can hear in my background me flipping the pages as I'm looking at these problems, just because it's easy to get lost. I'm not saying it's very difficult to do this, but I like how they set it up as a table that Alyssa, who gets a job done in 3 hours, well, that means that the rate, or how much of the job she can get done in 1 hour. So if she works for 1 hour, so if she works for 1 hour, she can get 1/3 of the, what was it, of the cleaning cages done. And the same thing is for Bill, who can get a job done in 2 hours. Well, if he only works for an hour, he can get half of it done. So let's just talk about that for a second. Well, if they work together, and let's say they're working for 1 hour, well then Alyssa will be 1/3 of the way done with the job. Bill will be halfway done with the job. Well, 1/2 plus 1/3, if you do the math, it's 5/6. So they're almost done after 1 hour. So I know for a fact that this job will take more than 1 hour, but less than 2 hours, because Bill could do it by himself in 2 hours, which is where the together comes from. Together. It would take T hours, which is what we're going to solve for, which would be in 1 hour they could get 1/T of the job done, which is basically what it boils down to. So that 1/2 plus 1/3 would equal 1/T. But even though I just gave you that answer, I'll go ahead and work this out the way I would do this, which is getting the same denominator, which would be multiplying by 6t. So as I distribute 6 to all of these terms, 6 divided by 2 is 3t. 6 divided by 3 is 2t. And then the t's would cancel out, so 1 times 6 is 6. So we have 5t is equal to 6. So t would take 6/5 hours. So you don't have to switch anything. If you would rather write this as 1.2 hours, you'll get full credit. I would hesitate to have you guys change this to be 1 hour and 20 minutes, because that's wrong. It's 1/5 of the, and I don't have my calculator next to me, but if you wanted to change this to minutes, you would truncate it. So take 0.2 times 60 which would be 12 minutes if my head is correct. 1 hour, 12 minutes. If you wanted to convert, but you do not have to. You can write it any of these different ways. But I believe there's a few word problems like this as well for you to practice, or on the test. Test is coming up. And one more, which I think is a good question, is why I'm assigning it, is these upstream, downstream problems. I think earlier in the year we talked about an airplane with the wind, airplane against the wind, things like that. But this is just a distance equals rate times time problem. So let's read the problem first. We have a tugboat takes 5/3 times as long to go 100 miles upstream along the Mississippi. If the speed of the current in the Mississippi River is 2 miles per hour, find the speed of the tugboat in still water. So I like how the book explains it. That's why I have the book open. I'm saying you should also look it up. It's not very often I like the way the book explains it. So upstream, we're going 100 miles, which we're going the same downstream. So that the rate that we're going, let's see. Well, if we're going upstream, I always hate this. We don't know the speed of the boat, but the current of 2 miles per hour is going to be going against it. So the rate would be x minus 2 there. Whereas if we go downstream, it's going to add 2 miles per hour to that speed. And then the time that it takes, well, we have to think about it for a second. Is that time is equal to distance divided by the rate. So if we were to examine this, upstream is 100, miles, divided by x minus 2. And then downstream would be 100 miles divided by x plus 2. So this is what we really want to examine, these two pieces. Because then we'll return to this statement that it takes 5/3 times as long to go 100 miles upstream along, instead of downstream. So what that means is I'm going to take that 5/3, I'm going to multiply by the time downstream, so that's that 100 times x plus 2 would equal the amount of time it takes us to go, I think I said it wrong earlier, upstream. So this is how we would set up that equation, and now we're ready to solve. And what I would do is multiply both sides by 3 x plus 2 x minus 2. Write that over here as well, 3 x plus 2 x minus 2. And what you'll notice is the x minus 2's cancel on this side, so it'd be 300 that we have to distribute. 2 times 300 is 600. And then on this side, the 3's cancel, the x plus 2's cancel, so it's 500 that we have to distribute. So it'd be 500x minus 1,000, right? Yeah, 5 times 2 is 10 with 2 more zeros. So then I would subtract 300 this way, so 200x, and add 1,000 the other way, 1,600. So as I divide both sides by 200, those would cancel. 16 divided by 2 would be 8 miles per hour. And I hit right at the end of the time. So hopefully all that made sense. Otherwise, rewatch the video or write down your questions. Not too many problems here, but they're mostly word problems. But here's your assignment that you should be ready to go accomplish now. And so write down questions if you have them, come to class, and hopefully I can answer them. And then we'll move on to the last section.